So next we're going to learn all about quadratic equations. So these are going to be equations that can be written in a specific form where you have some constant times x squared, constant times b, constant times c equaling 0. A, b, and c themselves are going to be real numbers, but this coefficient out front cannot equal 0. Otherwise, that would just be a linear equation. So this is going to be our goal. How do we solve problems of this type? And this specific form where you have everything on one side equaling 0 is called standard form. So a property we're going to use really frequently is if you have a times b, remember that's going to force that one of those is 0. Either a itself is 0, b is 0, or they both could be 0. But this is our zero factor property, which we're going to utilize to solve these equations. So let's start by solving x squared minus 5x plus 6 equals 0. So if you can factor, go ahead. We can actually utilize this one. So it factors nicely into x minus 3 times x minus 2. And then we can utilize our zero product property. The product of these is zeros. That tells you that x minus 3 must equal 0, or x minus 2 is 0. So if you solve both of these linear equations for x is going to equal 3, or x is going to equal 2. So you end up with two solutions, positive 3 and positive 2. If you have some type of a simpler equation, like x squared equals 9, so you're missing that middle term, you can absolutely move the 9 over and then undo the square by taking a square root. You just have to be really careful when you do that. It's a second degree equation. There's possibly two solutions. So when you go through this, you're going to have two answers, 3 and negative 3. Because 3 times 3 is 9. Negative 3 times negative 3 is also 9. So there are two answers. So be careful when you take a square root. You need to make sure to take a plus or minus sign. So if we start with x squared equaling 9, we take that square root, but put the plus or minus. So you get x equals plus or minus root 9. So x equals plus or minus 3. So we get our two answers from here. So let's go and use this method to solve this equation. We've already got something squared equals 12. So what we want to do is go ahead and just take a square root of both sides. And because we're taking a square root, one of them has to get a plus or minus. So we'll go ahead and do that on the right-hand side. But taking the square root on the left will make that square cancel. Now we want to go ahead and solve this for x itself, but I can do a little bit of simplification with that root 12. So you can write 12 as 4 times 3, and 4 is a perfect square. So it becomes 2 root 3. And then you can go ahead and also move this 1 over by adding it to the other side. And you want your values of x, so then you just go ahead and divide by 3 to get your two solutions. One being 1 plus 2 root 3 over 3, the other being 1 minus 2 root 3 over 3. So the next method we could use is by completing the square. This is probably your most tedious method, and it's the one you're going to want to use the least, but you don't want to just completely toss this method out. We're going to need it for other things. So what you need to do is we need to make sure we isolate the x terms first, and then we want to take the coefficient out of the x squared. And our goal is to make it a perfect square to be able to do exactly what we just did above. Take a square root, you get that plus or minus answer. So the first thing I want to do is isolate these x terms. So we're going to go ahead and we're going to move the 6 to the other side. Now I want to go and factor out that coefficient in front of the x squared. So I need to take out this 5. By doing that, I need to make sure I also take it out of the 10. So 5 times 2 will give us the 10. Okay. Now our goal is to add something right here to make x squared minus 2x plus whatever a perfect square. And the specific thing you're going to add is that coefficient in front of x, so in this case negative 2, divided by 2 squared. If this was a 5 in here, you'd add 5 over 2 squared. So we're going to add this, which is going to be negative 2 over 2 squared. And we get that's equal to negative 6. So negative 2 over 2 is negative 1. So really we're adding 1. But there's something I didn't account for. So I just added something that ultimately changed my equation. I really have to go back and balance out what I've done. So I didn't just add a 1 here, I added 5 times 1. And at all steps beforehand, I added this times 5. So I really added 5 to the left. So to counterbalance it, I've got to add 5 to the right. So you need to make sure what you do to one side, you do the other. But now we've got our correct perfect square, because x squared minus 2x plus 1 becomes x minus 1 squared. So it factors really nicely. On the right-hand side, that's going to be positive 1. So now we've gone ahead and we've got a perfect square. We're going to do what we did in the last problem and just isolate that squared factor. So I need to go ahead and divide by 5. So we get x minus 1 squared is negative 1/5. Now we can go ahead and we can take a square root. And if we take a square root, we need to make sure we put that plus or minus on the one-hand side. And then we go ahead and we add that 1 over. And because we're taking a square root of something negative, we get the I that pops out with it. So we add the 1 over and we get 2 solutions. X equals 1 plus square root of 1 over 5, I. And then 1 minus square root of 1 over 5i. Now, if it does tell us that we need to rationalize, we don't tend to like radicals in the denominator, we've got to go through a little bit extra algebra. We can take the square root of the numerator and denominator separately. So that's 1 over root 5. And then to rationalize, multiply by root 5. So in a nicer form, this is 1 plus or minus root 5 over 5i. So the very last method we can use to solve equations is ones that's never going to fail. Same thing, completing the square doesn't fail, but it's going to give you some nasty numbers sometimes, and it can be a little bit tedious. So this is going to be kind of your never fail method. If you want to solve ax squared plus bx plus c equals 0, then we're going to have 2 different solutions, and that's going to be given by our quadratic formula. So you can sing this to the tune of Pop Goes the Weasel. There's a couple other things you can sing to that I don't remember. But the values of x that will satisfy this equation are negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quantity that's actually underneath this radical is given a special name because it'll tell us a lot about the types of solutions and how many solutions we're actually going to have. So it's called our discriminant. So we have a nice little chart that kind of tells us what goes on. Based on the discriminant value, we'll know the exact number of solutions. So if what's underneath the radical is positive, then back up here, you're going to get plus or minus 2 real numbers because it's going to be the square root of a positive number. So you're going to have 2 solutions, both of them are going to be real. In the case that this is exactly equal to 0, then this whole thing is going to be gone and I really only get 1 solution and it's going to be a nice rational number. In the case that this is less than 0, we're going to be taking the square root of a negative number, so we're going to end up with imaginary solutions. So based on that discriminant value, we'll know a lot of information. So let's go ahead and let's just solve using the quadratic formula. So we've got the expression 4y squared equals negative 6y plus 9. So before I pick off my values of a, b, and c, you need to get this in standard form. So you have to move everything to one side. So we'll go ahead and move everything to the left to keep the y squared term positive. So we get 4y squared plus 6y minus 9 equals 0. And now I can immediately pick off that a is equal to 4, b is 6, and c is negative 9. So using our quadratic formula, we're going to get our two solutions. So y is equal to negative 6 plus or minus the square root of 6 squared minus 4. A is 4, c is negative 9, all over 2a. So now we just need to go ahead and condense and simplify and put in the appropriate form. So 6 squared is 36. Negative 4 times negative 9 is 144, and our denominator is just going to be 8. So going ahead and adding those, we get the square root of 180, which we need to clean up a tiny bit. So the biggest perfect square we can take out, we can write it as 36 times 5 to pull a 6 out. And then we can even do some simplification because really everything's divisible by 2. You can go ahead and split this fraction since you can split across addition and subtraction in the numerator. And then each of these 6 over 8s we can reduce to 3 over 4. So these are going to be the simplest forms, or the most simplified forms of our answers. Okay. So you can use whatever method. You don't want to, again, completely get rid of one. You've got to know them all because the techniques themselves are going to be important.